Today we review the first two sections of the APCS curriculum for review for the test. This includes primitive types, which are exemplified here, where we have local variables A, B, and C assigned to, in the first case, A is not assigned. It's simply declared as a variable. B is declared as a double and assigned to the value 1.1. And C is declared as a Boolean and assigned to the value true. Notice that the types of each one of these is not capitalized. Usually the convention is for a class or an object, the type is capitalized. So primitives have that special status. You want to be able to assign a primitive type of value to a static field as well. Here we have count, and if you look above this line of code, you do not see anywhere in the code the declaration of count. This should cause you some concern if you were to look at your own code. And in fact, way down here, past the main method, I have declared a private static integer field called count, and thus count is defined to be able to be assigned the value of 7 here on line 10. On line 12, we have a little trick, and it's worth you knowing this trick, and if you understand this line of code, then that's a sign that you're fine when it comes to primitives. What we're doing is we're taking B and we're adding 0.5 to it, and then we're casting it as an integer. When we say cast, what you should think is a type inside of parentheses like this. And so what that does is it takes B plus 0.5, which is going to be a double precision number, and converts it into an integer, and then we assign it to A. So that's section 1 of the curriculum. Section 2 is using objects. Now you need to be able to use an object that has been defined for you. We spend a lot of time in this class creating classes, but the amount of time we spend using classes created by others is rather less. Here I've invoked a constructor for a class of type fraction, and I'm not showing you the code for fraction, even though you see over here the file fraction is here. I'm not going to show it to you, but that doesn't mean that you shouldn't be able to use it. You should be able to use it. And so indeed, when we create a fraction, I could specify for you that the 4 and the 6 correspond to the numerator and the denominator respectively. And I've created a variable whose name is 2/3, and its value is indeed the object of type fraction returned by the constructor fraction with the arguments 4 and 6. Now then, there's a whole taxonomy of different kinds of methods that you can invoke in this context then. You can invoke a non-static void method with no parameters. So here what that means is if it's non-static, that means that we have some object with respect to that we invoke the method. So 2/3 dot means that 2/3 is the object we're invoking the method with respect to, and that makes it non-static. It's a void method because there's nothing that is returned by the method. And so you'll see this line of code doesn't have an assignment. We don't print out the result. We simply invoke the method. And you'll notice the parentheses are empty, and that means it has no parameters. So now we can taxonomize, which means to list all the different ways of invoking methods. Either they're static or they're not static. The method is void or it's not void. The method has parameters or it doesn't. And we'll look at a few of these examples. Here we have a static void method with parameters. So we invoke increase count with the argument 5. The way I do this is that you'll notice that there is no instance identified. And so one way you can do that is from within a particular class that you are in. And so I wrote the method increment count down here. And so then I was able to invoke it right here. So we're going to have to create a second video concerning string objects and beyond to complete both units that we're going to try and cover today.